This is the recording of the lesson for the habilitation that I have just recently done. The topic of the session is technology, meaning, and entrepreneurial action. And you will see that I will make emphasis on this constructivist view, on these three elements that I've just mentioned. First of all, it's important for me to define and explain what do we understand as technology here. We build upon the work of Brian Arthur on the nature of technology, where he proposes different views or different understandings, definitions that are potentially complementary of what is a technology. And we focus on two of those definitions that he uses. Technology as means to fulfill a human purpose. This could sound like a tool. And technology as an assemblage of practices and components. The third definition is more related to the way that society works and develops with technologies and sees technologies and defines technologies. But for the purpose of this talk, we stick to the two more operational definitions. So I would like to be talking about people that are involved in trying to bring scientific discoveries, developments in technology into the market. And we have two nice examples that have also recently been recognized. These are Ugur and Özlem, both of them co-founders of BioNTech. And let's just for a second also pay attention on how somebody that was in an established company in the industry, the CEO of Pfizer, Albert Bourla, talking about them. They were saying he, in this case, cares only about science. Discussing business is not his cup of tea. He doesn't like it at all. He's a scientist, a man of principles. And then he was mentioning that he fully trusted him. Interestingly enough, BioNTech is one of the largest biotech companies that we have now in Europe. So business is not such a bad thing for them. What is interesting and we would like to keep them, is these different roles that scientists, discoverers, inventors can take in the process of bringing new technologies to market. I would like to cover three main topics. The first one is to try to explain where are we, where did we get started on unpacking the relationships between technology and entrepreneurship. Then I would like to share some of the developments that we have been also contributing to on decoding and uncovering some of those underlying elements in this relationship. And I will finalize also explaining how at at the University of Stuttgart, we are trying to push forward the boundaries of what we know on these topics through different projects where we are working. So let's set the scene by trying to revisit this somewhat distant relationship between technology development and entrepreneurship. Sometimes it coincides, sometimes it's a quite distant relationship. So there are three, at least, truths that I would like to put on the table, and then we see how we can move beyond those initial statements. First of all is this idea that new ventures that build around new or emerging technologies are very slow to get to the market, so that they take a long time. An example that we tend to use are academic spin-offs. An observation from Bart Clarice and colleagues when they were looking at different types of academics spin-offs and their journeys, they were saying, like, look, in general, on average, it takes a long time before the technology is being exploited, and even longer until the moment that it starts to generate revenues. So we have this underlying assumption that technology, when it's new, takes a long time to get to the market. The second point that we also observe and we see is that in general, especially from the literature that comes from innovation and entrepreneurship, we tend to work with technology as a homogeneous resource, even if we want to follow the resource-based view on assets that companies have. So it's seen as a resource. The more you have, the more patents you have, the better you might be. And that's why, similar to what has happened to R&D activities, it tends to be simplified and on operationalization, where we just basically look at intensity, quantity elements. An interesting deviation from this trend is the work from Sam Arts and colleagues on technology differentiation, like looking a bit more in depth what is inside when we say that the firm has technology or firm is working on with technology. And the third point that connects also this technology and entrepreneurship element is that the most common differentiation that we have been doing most of the last decades has been to classify firms between high tech and low tech. My PhD thesis that at that time was an early step on this topic was looking at high growth technology firms, HTPFs, and that at that time it was something that we wanted to pay more attention and understand better in comparison to low or normal ventures. But as I hope I'm also sending this point across now, you can see that this is a quite of a simplistic categorization. So what do we see, or what can we discuss about this? So the first point about that it takes time. So, well, yeah, indeed. Sometimes it takes a long time. Just think, for example, the case of discoveries of new technologies that I like a lot. The case of mRNA is a very useful and illustrative case of different elements that later we will be talking about. So if you pay attention on the table on the right, or the element, graphic element on the right, you will see that it's taken more than 50, 60 years since the moment that they started to discover the technology, let's say, this new possibility, until the moment that actually you can start to launch or do some first products, first full tests. In addition to that, you can also see when some of the famous companies, CureVac, BioNTech, Moderna, that were built around this technology, interestingly enough, all of them new ventures. So you can see there is a comment also that some companies like Novartis and Shire were opening divisions of mRNA, but this was mostly new entrants, so entrepreneurs that were getting in. What is also a first kind of element that appears here that is also interesting is that actually here we see that the early applications, as if you go and you look upwards, were aiming or targeting oncology as a therapeutic area. Interestingly, as we know, the mRNA, the first clear use case that actually allowed some of those companies to start to invest in further development was in vaccines with viruses, not necessarily with mutations or cancerogenous cells. The other element that we might have to reconsider is the idea of homogeneity in technology. So if we look at the technology and we treat technology as a homogeneous kind of a monolith, kind of a big piece of that is the same material and it has the same shape, actually we get quite challenged when we look at technological trajectories. The work of Andriani and Gino Catani and other colleagues on technologies and their trajectories is actually very illustrative on this point, either looking at the coal tar or looking in this more recent paper on the evolution of the Corning glass. But we see here that, well, the nucleation theory and method that allow us to produce glass and develop better types of glass, and in this case, photosensitive glass. Yes, it started in the 50s and the 60s, but you see that there is a quick ramification of different types of applications, from light modulation, the ability to treat them chemically, light intensity modulation again, or even some ability to add or new functions on pollution absorption that allows us to develop the catalytic converters later on. So the variety of actually applications and technology functions appears with time. This starts to pose and to bring some additional questions that deserve more attention. For example, how does technology evolve? So if we only think about technology as a high or low, we actually miss out on the different theories, methods that are developed around the technology, how its kind of even materiality starts to change. More importantly, how do new functions appear? Not only that it's applied to a new market or new use case, but actually a completely different function. If you, again, you think about signaling or sunglasses, or you think about optical fiber, those are very different functions on the same kind of original technology. And also quite interesting is all the different products and services that can come out of those. For us also, in this more, you could call it constructivist view, we are also interested in who makes them evolve, in which context, and actually who benefits also from this evolution. Who are the drivers and who actually is able to capture value. So we would like to propose to consider at least that we might have to start looking at technology, paying a bit more attention to these elements of the nature of the technology, considering that there are multiple actors, they have different roles, sometimes the roles are mutated, they are changed, that maybe the paths are non-linear, and actually that they might be very context dependent. So if we think from left to right that there is an inventor that takes the role of a creator, gives meaning to the technology, it also has certain intentionality. It tries to assign a function to that technology. Borrowing from what Max Bozot would say is looks like a process where they are encoding knowledge into an artifact, into a piece of technology. This technology, using the definition of Brian Arthur, then it will be something like a combination of practices and components, in a very pragmatic way. However, this technology can be repurposed, reinterpreted, and recombined. It's also important to understand that the technology by itself will have also then interdependencies and hierarchies, and also relations with other technologies. We'll later talk about this point a bit more. For us, what is also even more important is to understand what happens once those technologies have been created. Who is able to also then give additional meanings? What we like to claim is that those entrepreneurs, sometimes they might also be the inventors, so they might be also on the other side, but actually they explore, they generate alternative paths and functions. They engage in a lot of those also meaning-making options for the technology. Finally, also equally important is the role that users in the market might be taking, where they also explore emerging users, maybe not the ones originally thought, and combinations. You could say that those users that put in practice the technology, actually they are decoding knowledge because they are finding different ways, or they learn new things through the use of that technology. That maybe then gets reintroduced in this loop or in this iteration. So in our work, we've been discussing also that there are underlying elements in this complex relationship where that we need to pay more attention. Just to give you a brief example, so what we becomes kind of quite visible and quite apparent once it's discussed. When we consider the differences in materiality of the technology, it becomes quite clear that maybe the way that drones or the mRNA, or more recently the AI, the way that they have developed and the way that have been adopted, depending on where you put the cutoff point, but the part of the recent AI developments have been quite quick, but you could also go back to the original conceptualizations of what is actually artificial intelligence versus human intelligence. But definitely some of the pickup of the materializations of that technology have been much faster than in other cases. What is also for us important to highlight is that the position that those technologies, when they are developed, have is not always the same. We would like to highlight that some of them take more the role of being supporting technologies. Some technologies might not appear to be the most sexy or the most attractive ones, but actually they are the ones that actually allow us to produce and leverage the value of other technologies. That's what we also like to talk about, these production technologies. And we also know that some of them are quite stable in their functionality. They are narrow, they have limited malleability, limited abilities to transform and being reused or recombined with other technologies. While some of them, we like to call them these general purpose technologies, they might actually have a lot of capacity to be reused, redeployed, reinvented, or reimagined in another context. In some of the work that we've been doing, trying to put in some way order in previous research, looking at this and how this influenced the commercialization paths, something that we actually found out that was relevant to explain this relationship is that entrepreneurs might have advantages in some of those types of technologies, but not in others. We, for example, were able to identify that based on the previous research that has been done, when it comes to GPTs, the general purpose technologies, you can think here about the electric motors or even the internet. Sometimes entrepreneurs have an advantage to launch them and develop them. You could even almost discuss whether mRNA can become a GPT when it's actually being used and redeployed to different types of applications inside the medical area. And we also see that entrepreneurs in those situations might be able actually to challenge those that are established players that are already in the market. There is also something that we find quite relevant and interesting, is that when we were looking at that figure that had the inventor or developer on the left side, there is also something that shapes the way that those inventors or creators see the whole picture. We could call this something like the creator's curse, where we actually identify that those that are involved in those tasks of inventing or developing a new technology, most of the times they already have a cognition of an image of the function that they are aiming to develop or create. This creates two potential tensions. On one side, having a functional image of what you're looking for or what you're trying to do might limit or direct your search options when you are in this process of discovering a new technology. So you might not be looking everywhere. You already are looking for something that resembles that functional image that you have in your head that you are trying to develop. Similarly, if you are more in those processes where you are actually trying to create or develop or giving this making to a new technology, giving this meaning, you might actually be constrained in your scope, on your span of application search. That's what we like to call this functional fixedness, that actually makes you sometimes too narrow, too early in the exploration as you look for possible applications. What this explains is something that we more and more realize, that we have several latent functionalities that have not been activated. We like to call them like dormants or shadow options, but it's also this concept that has been already used for a while, that we leave these adjacent possibilities and underexplored or unexplored. We did also work with, actually this was in a very nice setup or context that allowed us to get postdocs or early career researchers that were developing new technologies in a physics lab, that they actually partnered and team up with the students in order to be able to challenge their own biases and limitations when it was coming to trying to give meaning to that technology that they were developing. Most of the time, that technology or the work of the lab had been funded with an initial or tentative application in mind. But this tentative application in mind was maybe only one of the multiple possibilities that that technology could have. In order to be able to expand this and broaden this, something that was successfully done was to bring students that were taking more the role of almost like a co-founder during the project and try to explore alternative possibilities. This is something that was particularly exciting because it allowed some of those scientists gain further flexibility and understanding on how they could work or deal with these possible alternative elements that could come up as possible options for their technology in the future, broadening their scope of search. So we are in a situation where we have those entrepreneurs that sometimes are scientists, but they are also entrepreneurs that enter because they see a potential interesting technology that could be relevant for them to bring into the market. We see these as two very different approaches. So that's why I like to call this a kind of a two-sided story. So first, as a scientist entrepreneur, you know that you are likely to be assessed based on the expected functional application for the technology. So whether you perform well or you don't perform well will be based on whether your technology that you are developing is actually fulfilling the expectations that are out there. So if you're developing new material for a piston, you're expected that this will overcome or will be better performing than other existing pistons in the market. What happens is that this often restricts further exploration. This is something that actually works if the focus is purely on commercialization of a specific discovery. Very nice work from Marx and Su. We can see that actually those that team up or that have a commercialization experience in their team, they are able actually to bring those new technologies and discoveries into fruition, into the market, versus those that don't have those experiences. Also, from the other perspective of the other side of the story is this market-oriented entrepreneur, that actually what it does is it tries to find what is the optimal application for an existing technology, and then they try to have this perfect match. This there is interesting work on when people look again at patents and how their prior knowledge actually shapes the connections of the dots that they are able to see those relationships that other people cannot see. However, again, this limits the engagement in exploring further applications or functions of that technology. This is a very much exploitation route. So this, you see the two nodes and you connect them, but once you connect them, you focus on the exploitation aspect. And this makes sense, and this is something that we observe repeatedly. However, this creates another interesting puzzle. That is, those entrepreneurs, either the scientist entrepreneur or the market-oriented entrepreneur that goes in and tries to find this perfect combination, they operate in a set of conditions that are what the variables that in their context are well seen or well perceived as relevant or important. What ends up happening is that then those elements that are not societal priorities or that are not well kind of rewarded like through funding, but are, societal priorities, might be actually get unattended. So those diseases that are equally maybe important, but are not easy to monetize, or those nutrition problems or food health or availability challenges that affect certain regions of the world, where maybe some of those actors that are involved in this connecting the technology and entrepreneurship activity are not there, or they are not that familiar. Those are problems that become unobserved or understudied or unattended in general. So this creates an interesting dilemma on how much are we actually living out at the table. Not only those combinations of technology that could have been interesting, but it already starts to tell us that when those combinations happen, it might be happening with a strong bias or strong direction towards a specific set or type of incentives. So considering all those elements and different aspects that for us are relevant or important, we try to see how we are bringing this conversation forward here at both ENI and at the University of Stuttgart. So one thing that we've been doing, and this is the different projects that I'm sharing now are in different stages. So the first one is in the process of being revised and resubmitted. Hopefully this time we get managed to convince the reviewers, but the other projects are either they are full drafts that have not yet been submitted for publication, or in the last case, it's a project that we are just starting. So this first project actually builds upon an European project called Fucosan, that actually had the ambition to go from the production of algae to the extraction, to create a data set, and to that be able to identify 3 possible potential applications, and then be able to develop a business model around those applications. Now, just to give a bit more of context, those were it's a brown algae, and the specific name of the extract that you get out from this algae is called fucoidan. Maybe some of you have heard about this. Definitely, maybe some of you are familiar with this project. So what did we find after studying the evolution of the network of collaborators? So here we had active actors from the scientific side, but also from the industrial side, and even some entrepreneurs, some, in this case, recently created companies that were working in this space. If you are curious, this is a project that mostly the actors and the region that is mostly involved is the Schleswig-Holstein and South Denmark area. The first challenge that we identify is this, the difficulties when we need to work in an interdisciplinary setup. There is a clear challenge for collaboration. And not that there is no willingness to collaborate, but actually the different academic disciplines and scientific fields, in this case biology, biochemistry, ophthalmology, dermatology, they actually, when they need to interoperate to create a value chain, they actually are in a situation where they really speak different languages. When the colleagues from biology are trying to discuss what is the volume of, in this case, algae or raw material that the colleagues of ophthalmology need, the colleagues of ophthalmology or dermatology, they expect similar numbers or components, or like the quantities that they are working with. And they want to know, for example, to have a high control on the toxicity of the active principle that they will be using. This is something then that the colleagues from biochemistry, they have to work and connect the two dots, but that becomes very difficult to connect the two different nodes. Another element that challenges is that there appear in a recurrent way, there are paradoxical decisions in the innovation direction. So very early on, this was a very exploratory project when there was initial tests from those extracts that completed the whole process. The initial tests were done to try to see whether we could identify activity against cancer cells. So basically trying to see whether the fucoidan as an extract could have an impact to treat cancer or specific types of cancers. So those tests are not cheap, but this already shows that there is this expectation or willingness to make some of those early stage discoveries fit with a set of goals that might not be actually at all related with the characteristics of the technology, only as a kind of illusion that this might be a way to kind of hit the jackpot. So in this this process that we studied during a couple of years, what we ended up also finding is that there is a bottleneck that it's hard to solve for this type of journeys. And in this case is when you have a natural biological structure, the functions are also associated to this biological structure. And until the moment that you decode all the different functions or the different levels of toxicity and other aspects are related to the biological structure, you cannot advance. And in this case, the variability of these natural species, like in different different seasons of the year, whether it's Fucus vesiculosus or Serratus or other elements, this makes it very complicated to stabilize and to be able to build a value structure around it. What we like to say is that this limits quite a lot the industry and entrepreneurial interest until the moment that this has been decoded. And this is not decoded unless you invest a lot. So there is this situation that it's difficult to unlock. A different project, this time not that much focus on the technology, but much more focus on the inventors and developers that are aiming to explore alternative meanings, is that we would like to help those scientists, again, those inventors and developers of technology to maybe be able to display or lead their work following more their actually individual motives. And we can build upon some work that has pointed out that actually the commercial activities of academic scientists and engineers is not necessarily a space where we would expect to see those social motives at play, but actually they are more at play than we would initially have thought. So the meaning is that it's not only economic and scientific motives that drives the activities of those scientists and engineers. We also know that they might be having their interest and their individual social motivations, some impact goals. And actually what we would like to do with this work is that we would like to be able to promote or facilitate that there is a reactivation of this individual agency, and that we remember that technology is also a creation process where the individual can get involved and put a bit of himself in there. So at the end, what we try to do is that we try to bring back this human purpose around technology. The work that we've been doing on this has been to working in the context of the University of Stuttgart, where we have actually these more than 3,000 early career researchers, these PhD students and postdocs. And part of a training program that we have been offering, we work with an email that we were sending to all these potential audience to invite them for this training program. We designed the survey in a way that we were able to use two different types of frames. One of them that would very much look like the business as usual, the way that traditionally they have been approached when they are offered entrepreneurship training programs, that is highlighting that entrepreneurship is a path to economic benefits, and that they can actually maybe advance in the possibilities of doing a patent, and after that maybe they can create a company, and then they can maybe have some type of market success. Alternatively, we were looking at the possibility that actually we could frame this message as entrepreneurship as a path for a much broader societal impact, where actually the reason why you do entrepreneurship is to bring some of your ideas and visions into practice and to improve, in this case, the society around you, but much more open-ended, and where the individual could actually choose a bit more or see themselves a bit more reflected. This is a study that has been pre-registered. It was implemented now a couple of years ago, and it was executed as it was pre-registered and as planned. And actually, we have completed the data collection, and we are now doing different rounds of analysis of this data. There are some preliminary results that are relevant and interesting. First of all, the identification that our B option, this B treatment that we had, is actually as effective as the business as usual. So what does this mean for us? It means that we don't see a clear penalty for actually calling for social motives in relation to entrepreneurship. So this different way of framing entrepreneurship is not something that is perceived negatively or less interesting. It's actually more or less on average equally interesting. For us, this is something relevant if we consider that we are in a context of a university that actually most of the academic spin-offs or commercial successes have been linked to either mechanical engineering or chemistry or bioengineering. So disciplines that are by tradition very close to the market. So this was one of the first elements that we thought it was important to highlight. The other element that is also relevant is that we see that the text framing in an email, that is a very light touch type of intervention where we just ask people whether they are interested in learning more or seeing more about this program. It might not be enough to kind of untangle or break with maybe some of those perceptions that have persisted in the university context, especially with some disciplines, so that where entrepreneurship is not actually regarded as a normal path. This applies very specifically to some of the disciplines that have been unattended or more difficult to actually make visible in science valorization or commercialization, such as social sciences and humanities. Still, this is early work, so we still need we would like to replicate this study, maybe with some variations, and also maybe in other contexts or other groups, because we believe that this actually is the first step on trying to see how we can broaden what does entrepreneurship mean for some of those inventors and developers that might have options to think with their technology on applications that might not be the ones that they were initially thought to develop for. In a similar way, we've also been working or engaging, this time with both entrepreneurs and inventors and developers, and this is something that we are just starting now, where we look at the quantum sensing as an emerging technology. That's a project that also involves some of you here, either on the operation part or on the research part. And what for us it's interesting here is, so what allows those actors that are involved in science commercialization to keep open the set of possible outcomes? What does it mean still with the same framing as before? How could we keep as many options open before they start to close down or fix what is the application in order to further their exploitation? And we would like that this is done more later than earlier, especially in these very early emerging technologies. However, this hits with a paradox. How do you keep your options open because you are still not clear, but at the same time you need to build legitimacy to secure, in this case, easily external resources such as funding. And you want this funding because you need to keep both developing these market opportunities that you thought about, or you need the funding to actually keep developing the technology, and you are competing against maybe other groups or other centers that are advancing in this technology. And this happens in a technology that for us it's important for our university, but also quite important and relevant for some of our industrial partners in the region. You can think about, for example, Bosch. So our current thoughts here is that we should consider maybe that there is a positive side of ambiguity, but we know little on how to leverage ambiguity for its positive side. So most of the times, ambiguity is seen as an element that deters action, that makes things less clear. But we believe that there might be a possibility to use ambiguity to understand better how do those inventors and developers, those scientists, describe a technology functions so that they can maximize the possible interpretations and scope of applications. While at the same time, we also would like to know how do entrepreneurs and industrial partners describe the functional images of those technologies so that they can broaden their search. Because so in both cases, they would like to keep as many options open as they advance. So this has to happen in a way that it's still functional for both, so that it's still productive. So what we would like to argue is that there might be combinations of ambiguity in relation to the technology properties, the affordances. What does this technology actually do and do well? The functions that this has, okay, this helps to do the job that it does, no? It helps to measure better, to calculate better, to more accuracy. And the applications, whether depending on how you are balancing those elements, actually this might have not a negative effect, but a positive effect. We kind of hypothesize, or we have insights that support the idea that leveraging ambiguity in a smart way might be able to facilitate the spaces for co-creation between actors that are distant in many senses, but it's this university and industry actors. So this allows for spaces where we kind of, in the confusion, we understand each other because we find common languages where we can operate and things that we can accept. And in parallel, this also means that we might be able to allow for multiple meanings of this technology to coexist. This means that we can somewhat break this dichotomous relationship between either you are exploring or exploiting. Actually, they might be able to be involved in tasks where both things are happening at the same time, and it's not, or none of them are happening at the same time. So this is almost like these quantum states. So trying to bring this to the end, something that we've been aiming, and I think it's important, is that sometimes we do work, or we discuss specific aspects of research or thoughts, and we wonder whether we are just putting one brick on top of the other one, the, the, the characterization on the left, where we actually think that we almost built a wall. So we actually accumulated pieces of knowledge that start to make sense and actually are useful for something, and actually that we would like not to forget, like, in which big conversations are we joining, which big puzzling questions are we trying to build on or contribute to. So with this story of the different bricklayers and their different visions or missions of what they are doing, versus the person that just puts on bricks, the person that thinks that he's just building a wall, and the one that actually has the whole picture of that we are building a temple. We think that we've been progressing in this. Maybe our temple is try to further and advance the understanding of technology and entrepreneurial action, and how those two elements interact and help each other, and suggesting that actually the way that we build, or the way we are contributing in this broader story, is that we are paying attention to technology heterogeneity and the meaning, who creates meaning, who gives meaning, and how these decomposing, encoding, decoding processes happen, considering the substantial differences and characteristics of the technology. So to summarize, the work that we have been doing and we plan to continue doing tries to hit on these, at least these three main blocks. So we challenge the viewers of the homogeneous and monolithic view of what is a technology, and instead we try to introduce this much broader and nuanced view of technologies, considering the actors where they are, who takes the roles, and which context they are operating, what biases are coming in, what limitations are affecting them. Second point is that we actually also look at the much more, we would like to move away or advance this concept of a narrow and linear relationship between technology and market. So either it fits or it doesn't fit. Either there is demand or it doesn't demand, or there is no demand. So that is often mostly driven by the need of the moment, maybe related to funding and economic incentives. And we would like much more to promote also and to support actually development of technology and science that actually connects again or reconnects with the other motives and gives attention to the other motives that the scientists have to shape this technology and to create this technology. Again, bringing back the picture that I used at the beginning, the co-founders of BioNTech are a good example of individuals that actually have shown in their trajectory this caring also about having additional motives, not just to develop a technology or to satisfy one specific need. And this actually, we believe that this actually can also influence and impact the direction of the innovation that they follow. Finally, the element that we also try to challenge is this whole idea that there is a strong path dependency, that the constraints that appear at the origin, the intended uses, those technologies cannot be recombined. So we would like to challenge the idea that you can analyze technologies in isolation. So we need to have this more ability to decipher how those exchanges across distant actors, across technologies are organized, and actually how this allows for phenomena like acceptation or other aspects where new functions appear, alternative meanings can appear, because we have been accumulating and we keep accumulating evidence that a lot of what we see and a lot of what we could see could be driven by those more systematic, more intentional efforts to expand our scopes of search. This is what I wanted to share. Thanks a lot for your time and attention.